Hello everybody. Today we're going to talk about classifying real numbers. And really we're just going to start talking about classifying real numbers because all we're going to focus on today is after we know a number is a real number, determining if that number is either rational or irrational. But before we do that, let's just talk about real numbers, okay? So real numbers are numbers that we use in everyday life or can use in everyday life, such as like jobs. Okay, or the workforce. We could use it in another area, like such as something that could benefit us in our personal life or everyday life. So real numbers are numbers we could use in our everyday lives, or in a job somewhere, or in a scientific field, things like that. Now, physically speaking, real numbers are numbers that could be graphed on a number line. So any number that could be graphed on a number line is a real number. So if you think about it, we have positive numbers, right? Over to the right of 0. We have negative numbers. We have numbers in between these numbers. And by the way, the numbers that you see on each mark, those are called integers. Integers are your basic positive and negative numbers, including 0. But don't forget, we also have numbers in between these numbers, such as decimals and fractions, right? We have the square roots of numbers, so many other different numbers. We have mixed numbers like 2 and 1/4. That could be graphed in between 2 and 3. So all those numbers are real numbers, okay? So again, real numbers are numbers that we use in everyday life or in the job or in some type of workforce or scientific field or anything related to that. Or numbers, physically speaking, they're numbers that can be physically put on a number line or represented by a number line. So we have two main types of real numbers. We have what's called rational numbers, and the other type of real number we have is an irrational number. Okay? So any real number can be classified as either rational or irrational. So let's talk about the difference between rational and irrational numbers. So let's first start with rational numbers. Well, we have two main forms of a number. We have its decimal or its fraction. And first, let's start with the decimal. So rational numbers is decimals, okay? They're either what's called terminating decimals, meaning they stop, or repeating decimals. Now, terminating and repeating decimals are both types of decimals that are rational numbers. So let's look at some examples. All terminating means, guys, is that the decimal stops or comes to an end somewhere. So, for example, 0.35, that's a terminating decimal because it stops at the hundredths place of 5. Or, let's say we have 1.7. It stops at the 7. Or even something like 5 could be written as a terminating decimal because we could actually write that as 5.0, right? So, anytime the decimal stops and doesn't go on forever, or have a repeating pattern in it, that's considered a terminating decimal. It stops somewhere, okay? So terminating decimals are rational numbers. We also have what's called repeating decimals. And repeating decimals have a place value or multiple place values that repeat. So for example, I might have 1.555 repeating. Or you might see that same decimal written with a bar over top. Okay, that means the 5 keeps repeating. That's a repeating decimal. Or you could have 3 place values that repeat, or 2 place values, or many more. Such an example, we could have 4.787878 with dots. Now, if you see those 7/8s repeat, that means it keeps going on and on. Or this number could also be written like this. Okay? So anytime you have a repeating pattern that's exactly the same every time, that is a repeating decimal, and repeating decimals are also rational numbers, okay? Now, we also have a form of a number that's a fraction. So anytime a number is a fraction within this form, it's called a over b, where a and b are integers, more like your basic positive and negative numbers, okay? As long as those are your more basic numbers and it's a fraction, that's a rational number. So for example, 3/5, that's a fraction, meaning it's a rational number. Or 1/3, that's a rational number. Or 3 5/8. Now that's a mixed number, right? But remember, can we make any mixed number into a fraction? Of course we can. We can multiply here and add here, right? So that would be 29/8. So that's a rational number. Or if you think about our, integers, let's say I have the number -6, right? Now you might not say that's not a fraction, but we can take any integer and put it over 1, right? So it is a rational number. So again, just to recap, rational numbers as decimals, they're either terminating or repeating. But we could also have in a fraction form, as long as the numerator and denominator are integers, then it's a rational number, okay? Now let's talk about irrational numbers, okay? Irrational numbers cannot be written as fractions in the form of a over b, so it can't happen, okay? So really, we have to look at the decimal for irrational numbers, okay? And irrational numbers are non-terminating and also non-repeating. So I'll explain more what that means in a second. Okay, so basically, irrational numbers as decimals, if you're looking at the decimal, they don't stop and they don't have a repeating pattern in them. So for example, let's say we have 4.3175263 and there's dots at the end. That's an example of an irrational number. Okay? Now let's look at other irrational numbers. Please go get a calculator. So stop the video lesson. If you don't have a calculator, please go get a calculator. Okay, great. So I want you, if you have a more advanced calculator, to type in pi. Okay? And then hit the equal sign. And it might be tough for you to find, so you should see the pi symbol, or you might have to hit second and look for it written above a key, and then hit that key it's written above. So again, you might have to hit second, and then find that pi above a key and hit that. Okay? And then write down what it says. Okay, so hopefully you type pi in your calculator and hit equals, and you might have a couple numbers. So pi as a decimal, you actually can't represent pi, like the entire number, as a decimal, because it actually goes on forever. So it's 3.1415926, and you might have some numbers after that, but basically, when you typed it in your calculator will stop somewhere, because it can't fit all the numbers possibly. So we can't actually represent pi as a decimal. We'd have to round it at some point. But if you look at its decimal, see how the numbers, well, first of all, the decimal goes on forever, right? But also, if you notice, there's no pattern to the numbers, or no repeating pattern, it's the same. So that's an example, perfect example of an irrational number, okay? And other irrational numbers, usually square roots, or oftentimes, I should say, square roots of numbers are irrational. So not every square root of a number is irrational, of a positive number is irrational. So for example, if we have the square root of 4, that's 2, right? That's actually not irrational, because that's actually rational. It stops, so it could be written as a fraction. But let's say I have the square root of 5, right? Well, hopefully you have your calculator still. Find your square root symbol and type in the square root of 5, and what you'll see is a decimal that's 2.2360697, and depending upon your calculator, you might have some more numbers. But again, look at that, guys. This actually goes on forever. It's a bunch of random numbers, but your calculator just runs out of space. And then we do some more square roots. The square root of 6. Type that in your calculator. You get 2.4494897. And again, same thing. It goes on forever, but there's no pattern. The square root of 7. Type that in your calculator. So I'm showing you guys examples of irrational numbers, right? But look, notice that you're looking at the decimal, and see how the decimal is a bunch of crazy numbers that goes on forever, and there's no repeating pattern. That's an example of an irrational number, a perfect example. So here's my point, guys. Not every square root is irrational, but a lot of times they are. If the number underneath the square root is a perfect square, it won't be irrational. But a lot of times, the square root of integers, positive integers, are irrational numbers. Okay? All right, guys, so let's transition here. So what we're going to do is I'm going to give you some numbers, and I want you to tell me, now we know these are real numbers because they could all be graphed on a number line, and they're all numbers that you'd see or could see in everyday life. But we're going to decide whether they're rational or irrational. Okay? And hopefully you took good notes, guys. This section has a little bit of memorizing in it, so you want to make sure you took good notes on things we talked about earlier, so you know what you're doing here. All right? So first, 1/3. Well, that's not a decimal. Now, you can type that in your calculator. If you type in your calculator, you get 0.33 repeating. So either way you look at it, it's a fraction where the numerator and denominator are integers, so that's actually rational. Okay? But another way we could prove it's rational is because this is a repeating decimal. Repeating decimals are also rational. A rational number as a decimal is either a terminating decimal or a repeating decimal. And actually that goes true for number 2. This is a terminating decimal, so therefore it's rational. Okay? We could also represent 0.4 as a fraction if you remember that from earlier grades. You could write that as 4/10 because it occurs in the tenths place, which could be reduced to 2/5. But it's easiest just to look at the decimal. Since the decimal stops, it's rational. Now for number 3, I should have put dots on the end. But basically what we're trying to get at here is this number goes on forever, based on the dots, but has no pattern. Perfect example of an irrational number. Okay? Irrational numbers as decimals, they go on forever, no pattern. Okay? Square root of 5. I don't know if you remember that one, but if you type in your calculator, which you should, okay, to look at its decimal, you're going to get 2.23 and then a bunch of random numbers after it. So it's 606 and then 79, but it keeps going on forever. Again, like number 3, that's irrational. Okay? Goes on forever, no repeating pattern. Number 5, pi. Type that in your calculator, but you did go over that. Here's what I'll tell you guys, and here's a little shortcut. If you see pi or an operation happening to pi besides it being divided by itself, so unless it's pi divided by pi, if there's any other operation happening to pi, it's going to stay irrational. Pi is an irrational number. If you remember, it's 3.14 and then a bunch of random numbers after it. So pi is always irrational. Okay? Or an operation happening to pi is almost always irrational. So 6 and 7. You might be a little bit confused with these, but basically, if it can be written as a fraction, or if it is a fraction, it's rational. Well, I could write 6 as 6/1, right? Or we could also write -4 as -4/1. So guess what? These are both rational. Okay? Any number that's a fraction, or it can be written as a fraction where the numerator and denominator are basic integers, that's a rational number. And then finally, number 8. If you look, there's a bar over the 3/4, so that means it repeats, right? Well, repeating decimals are actually rational. Guys, all irrational numbers they're decimals that go on forever and have no pattern, okay? So if the decimal has a repeating pattern, or if it terminates, that's rational, okay? So I know there's a lot going on there, but really, guys, you have to kind of memorize and experience the difference between a rational number and an irrational number, because any real number can be classified into one of those two categories. So again, if you need to, go back and revisit the definitions and the examples of rational and irrational numbers. Here's a quick picture to end. Math is fun and you can do it, okay? So just keep that in mind at all times, all right? But just to recap, all numbers that we have in this class are going to be real numbers, excuse me. All right? Now, not all numbers are real, but in this class they will be. So when you're given a real number, you have to decide whether it's rational or irrational. Rational numbers can be written as fractions, right? Or as decimals. They either terminate or have a repeating pattern. Okay? Now, irrational numbers, they do go on forever, but there's no pattern, right? 5.131, oh, excuse me, that's not irrational. I meant to make it a bunch of random numbers. 1, 3, 8, 7, 5, 2. That's an example of irrational. Okay, it goes on forever with no pattern. If you see pi, as long as it's not being divided by pi, that's irrational. Okay, or a lot of times square roots are irrational. Not all square roots. The square root of perfect square integers are not irrational, but oftentimes the square root of numbers are irrational. Just type in your calculator and look at the decimal. Okay? So thank you very much for your attention. Hopefully you found this video lesson helpful. Remember this, guys. You can do it. Thank you very much and have a fantastic day.